The lithium-ion battery has been responsible for much of the modern human advancements. They have allowed us to use smartphones, laptops, and many other electronic devices. In fact, Tesla and the rest of the EV industry has a lot to thank the lithium-ion battery for, because it enabled EVs to have practical driving ranges. However, it is time for the next big thing in battery tech, and Elon Musk himself has admitted that a solid-state battery is the next stage in the evolution of the EV battery. Tesla got off to a good start with the Roadster, and most of that was due to one particular component in the speed racer: the battery. Instead of using a bulky and less efficient lead-acid battery that had been a staple of the early EVs, Tesla used a lithium-ion battery, giving the car an unprecedented driving range of above 200 miles. For the first time in the history of EVs, drivers could confidently embark on longer journeys. Elon Musk's companies would go on to innovate with its lithium batteries, culminating in the upcoming 4680 battery. Representing the best in EV battery, the 4680 battery offers longer driving ranges, reduced weight, higher energy efficiency, and enhanced safety. Tesla pulled all this off by making physical and chemical changes within the battery. For example, it eliminated the tab, a common feature in lithium-ion battery cells, and rearranged the component. Tesla also swapped out some of the raw materials used to make the battery. The 4680 battery will power Tesla's upcoming electric models like the Tesla Semi and Cybertruck. Tesla will also gradually introduce the battery into its existing models, starting with the Model S. However, despite the advancements or breakthroughs in the 4680, its successor is already here. It is a solid-state battery, and it is going to be the end of lithium-ion batteries as we know it now, for good reason. But why is Musk, who is a visionary, developing the lithium-ion battery when its replacement is already here? We will come to that, but before that, let's dive into how a solid-state battery wipes the floor with lithium-ion batteries. Batteries are among the most crucial components to an EV. The battery, for example, basically determines the sticker price of the EV because it is the most expensive single component. In fact, the general drop in the prices of EVs has been thanks to the reduction of the cost of the battery. Also, the battery determines how much the car weighs and is why EVs weigh more than their ICE equivalents. Most importantly, the battery is what determines how far you can go before you are forced to stop for a recharge. This is why so much research into the battery is going on at any single point in time. While the lithium-ion was getting better, battery scientists were already working on the solid-state battery. There are other types of battery being pursued, including graphene, but only the solid-state battery comes close to actually powering an EV. Lithium-ion batteries and solid-state batteries have a lot in common, so we will start with how lithium-ion batteries work. Unlike the lead-acid and nickel-metal hydride batteries of the past, lithium-ion batteries are constructed with a liquid electrolyte to manage a flow of energy between the cathode and anode. The benefits of a lithium-ion battery include longer battery life, better performance in varying temperatures, recyclable components, and higher energy density. Energy density is the amount of energy a battery can store per unit weight, so the higher the density, the higher the power output. However, even though there are many benefits, lithium-ion batteries have drawbacks. Although lighter than older battery technologies, its liquid inside still makes lithium ions quite heavy. They also perform better when in stackable packs, adding even more weight. Additionally, the electrolytes are flammable, can be unstable in extreme temperatures, and lead to explosions or fires if damaged or improperly charged. There is no shortage of news reports covering everything from cell phones to airplanes catching fire due to battery issues. So what solid-state batteries do is to do away with the sloshing flammable liquid electrolyte. Solid-state batteries. This makes them, by default, more stable and compact. The solid electrolyte can comprise any number of everyday materials like ceramics and glass. Solid-state batteries have been used in small devices like pacemakers and RFID, and wearable devices for years. Having fewer bits and pieces means fewer things can go wrong. So while lithium-ion batteries are subject to events like thermal runaway, leading to explosion and fire, the solid electrolytes used in solid-state batteries, which are non-flammable, present a lower risk of igniting a fire. While the battery may get hot, there is nothing flammable within it that will catch fire. Additionally, these batteries will require fewer safety systems than lithium-ion batteries do. Eliminating additional electronics can contribute to smaller, lighter-weight battery packages, enhancing solid-state batteries' energy density. These batteries may not even require an external BMS in certain situations, greatly simplifying its construction. In addition to improved safety, size, and stability, solid-state batteries in EVs would also offer faster charging times, more travel range, and even greater energy density. Solid-state batteries are said to be capable of delivering 2.5 times more energy density than current lithium-ion tech. This tremendous increase in solid-state batteries' energy density means that they will be far smaller and lighter. Higher energy density means that the batteries could be much lighter and store the same amount of energy. Weight is a critical concern for mobile power applications, so this could be a game changer. Cars, trucks, RVs, boats, and airplanes all could benefit from being lighter. In fact, solid-state batteries may be the remaining ingredient that Musk needs to make the electric jet he has always wanted to make. But electric vehicles in particular have much to gain from this technology, as they could get much more range with less weight and space in battery storage. This could mean we reach the 1,000-mile range mark. While passenger electric cars will no doubt benefit, the real segment that will benefit from lighter battery that lasts longer is the trucks. Due to the load they transport and the long distances they have to cover, electric trucks, for now, are practical for short-distance hauls. This is because of the compromise manufacturers have to make between battery weight and range, which probably explains why most semi-prototypes have day cabins. But with the solid-state battery, the Semi might be able to take on regional or cross-country deliveries confidently. One other important improvement solid-state batteries have is the charging speed. They can charge blazingly fast because they reach an 80% charge within 15 minutes. The implications of this are huge. EV drivers often complain how long it takes to charge their batteries, and this forces them to extend their battery charging stops while on long trips. But with solid-state batteries, there will be fewer stops for charging to start with due to the longer ranges. However, when you do have to stop, it will not be a long affair. Going back to the trucking industry, one problem electric fleet operators anticipate is the long charging times due to the massive sizes of the battery packs. Long breaks for charging will interrupt their delivery schedules, but with solid-state batteries offering shorter charging times, running an electric fleet begins to look more practical. A lithium-ion battery will begin to degrade and lose power capacity after 1,000 cycles. On the other hand, a solid-state battery will remain 90% of its capacity even after 5,000 cycles. To put this in perspective, Tesla will charge you between $5,000 to $7,000 to replace the car's battery. So it is a huge deal when solid-state batteries do not degrade as fast as lithium-ion batteries. Also, solid-state batteries are much easier to manufacture. Working with a volatile liquid that cannot be exposed to air is a huge challenge, but that could be wholly eliminated with the solid-state battery technology. Fewer complications means less production costs. In addition, a solid electrolyte could enable much faster production that uses less material and energy, further driving down the cost. Development costs and manufacturing difficulties are key factors in producing solid-state batteries for mass-market electric vehicles. But that is not a strange concept to battery makers. Lithium-ion batteries started off very expensive, but they steadily became more affordable. The same is expected to happen with solid-state batteries too. The cost will drop steadily until they become so much cheaper. Automakers are making huge investments in solid-state battery technology, especially with zero-emissions brand strategies and proposed EV-only lineups. For example, BMW and Ford are investing $130 million in Solid Power, a solid-state battery startup based in Colorado. Hyundai is also putting $100 million into Solid Energy Systems, a Massachusetts Institute of Technology spin-off company. Also making investments are General Motors and Volkswagen. Toyota is even more advanced in the race to produce solid-state batteries. They already have a working prototype car that is powered by its solid-state battery. Toyota is especially keen on battery as it tries to regain the ground it ceded to the competition when it comes to electric vehicles. Let's hear what you think of solid-state batteries in the comments section below.